All right, so the problem we left off on yesterday, and I told you we'll come back to it today because it was going to take a little bit longer than I was willing to commit to, is this problem right here. So SNO. So here's the deal. So my first question is, as a matter of fact, I'm going to come off of this so I can have a little bit more room. And I would advise you kind of writing this somewhere else so you have a little bit more room. So the deal we're trying to figure out is we're trying to do the name of this compound. Okay, so here's my first question. I need to determine the type of bond that this compound is. Okay, so what is, hang on, let me call on somebody. Massimo, what is SN? Tin, all right, okay. Gauge, is tin a metal? Yes, okay. Brennan, is it a special kind of metal? Is it a transition metal is more of my question. Is it under the stairs? Yes, so it is going to act like one. So we know that it's tin, so go ahead and do me a favor. Write this. Why did I write that? I'm gonna explain that. Okay? Alright. Jamila, you weren't here yesterday, so Jalen, I'm going to come to you. Jalen, anytime we write a transition metal, what has to be in the name? Well, then help him out. A Roman numeral. Very good. Now, let's go ahead and throw this at you because we're going to get to some of these. Now, all transition metals have to have Roman numerals, but how many exceptions were there? There were 3 exceptions, and who were the exceptions? Very good. Zinc, cadmium, and silver. So those are the 3 exceptions. So we're going to come back to this, and what I'm going to do is I'm just going to put a blank, and we're going to fill this blank in. Okay. So my second question is, will the final word in this, and Lily, this is for you, will it be monoxide? Why not? Very good. This is what type of bond we've already established? This is ionic, and ionic does not have prefixes. Very good. So Lily, it's not monooxide or monoxide, it's what? Just plain old regular oxide. All right, so here's the deal. I'm going to teach you a new little trend, okay? This is the hardest type of questions we can do. If you can do these, it doesn't get any harder. This is the hardest naming compound type. So once you see this, we're going to we'll be able to progress on. Now, the problem is I got to know what the Roman numeral is. So here's what I want you to write under this. So this is the spot for the Roman numeral. And my question to you is, what does, and I'm going to write this, I'm going to write it up here because I don't feel like bending over. What does the Roman numeral represent? Very good. This is the key word. The charge on the TM. Now what is TM? Transition metal. Okay. So that's the situation that we've really got to come to grips with, is that the Roman numeral represents the charge on the transition metal. Well, here's the deal. If I write, and I promise I'll come right back to this. I'm going to write it again. Where are charges located? Are they in the green circles or the brown circles? The green circles. What do we call this region up here? Superscript. Very good. So it's in the super area, and what are these regions? The sub. So these up here are going to be charges. Well, here's the deal. If I go back to this, do I have any numbers in those areas? No. I don't even have any numbers in my subscripts, but what's understood to be down there? 1. So this is what the process is called. Reverse crisscross. So here's what we're going to do. We're going to pretend that there's a 1 here and a 1 here. And what I'm going to do is I'm going to reverse crisscross these numbers. Haven't I already taught you the crisscross method? Basically, we're undoing what we've already done. And there's a reason why. You could. You can. But hold on. Let me get finished with this. Hang on 1 second, okay? Hang on 1 second. So, do you agree that up here we would have 1 plus and 1 minus? Yes. Now, if I asked you the question again, What does the Roman numeral represent? You've already told me. What does the Roman numeral represent? The charge. Now that we've done reverse crisscross, what is that number? A 1. So here's what you could, and again, don't write it yet. You would think that the Roman numeral for tin oxide is what? 1. Does anybody find anything wrong with that? Say it again. Is it or is it not? Say that again, Jamila. What's 2 negative? Oxygen. So let's look up there. Okay? So you just told me something's wrong. Now that's one way you know. Another way, remember when you all had to memorize that bottom box on the polyatomic sheet? 10 had how many possible states? 2 of them. Does anyone remember what 10's possible states were? 2 and 4. According to our numbers, this says 1. That's not possible. 10 does not have an oxidative state of 1. So something's wrong. So I'm going to change pages because there's a lot going on here, and I want to come back to it in a different perspective. So you just told me that this is 1 plus and this is 1 minus. And this is what I just told you at the very beginning. These are the hardest problems to do. So if you can figure this out, and we're going to do enough of these, I promise it'll click. It'll all make sense when we're done. Go ahead and ask your question. When I reversed crisscross. Okay, remember the numbers have to balance each other out to equal 0. Those numbers equal 0. The cation must always come first. Does that help? Gage. Assume it to be understood would be 1. Massimo, go ahead and ask your question now. Transition metal. Okay. All right, so Jamila and Terrell, you also caught this. You told me the problem was what? That number is supposed to be what number? How do you know that oxygen is supposed to be -2? It's in group 16. That is the hardest part about this, is that when you reverse crisscross, that you catch that something's wrong. Okay? So so what do you think we have to do? We got to fix it. Remember? We reversed crisscrossed. Okay? Remember, the cation must always be written first, and the anion must always be written second. Does that make sense? Okay. All right. So here's the process. And again, commit to the process. What did you just tell me oxygen has to be? 2. Multiply both numbers by the number that it's supposed to be. Multiply both numbers that what the oxygen is supposed to be. Well, what is 2 times +1? +2. What is -1 times 2? -2. So now, is the oxygen correct? So then what does that tell you about 10? It's correct. So which 10 is this? 10-2. Yes, sir. Essentially. Okay. So the answer is 10-2 oxide. All right. Let's do one more. Let's see if we can figure this one out. So what happens if we have PbS2? So write this one down. This is a whole other example. And again, I'm telling you, this is as hard as it gets. If you can get these, you can get any of them. All right. So my first question is, Tristan, Pb, what is Pb? It is lead. Bailey, is lead a metal? Yes. Okay. Blaze, what is S? It's a nonmetal. Okay. So we have a metal and a nonmetal. So what type of bond are we working with? Ionic. So what will we not have in our names? We won't have any prefixes. Okay. You've already told me it was lead. Now my question is lead one of those special metals? Does it need a transition? Excuse me, is it like a transition metal? Yes. It's under the stairs. If it's a transition metal and under stairs. Does that help? Yep. are 1 and 2. And that's it. Those will not need Roman numerals. Now remember, aren't there 3 exceptions to Roman numerals? Yeah, and you got to remember those. Okay. All right. So we've got lead, and then we know there's a Roman numeral, and then Jesus, what is S going to turn into? No. What's the name? Like lead blank something sulfide. That's what I was looking for. Lead something sulfide. All right. So again, we need to figure out the Roman numeral for lead. And again, what does the Roman numeral represent? And this, I've got to keep asking the same questions. The charge on the transition metal. How do we come up with a charge? What is that process called? Reverse crisscross. All right. So when I pull this up, that goes there. What's understood to be there? A 1. So we've got 2 plus and 1 minus. It's okay. That's okay. All right. And again, these are hard because you've got to catch that something happened. When you do this, you can't just automatically assume that it's going to be lead 2. Now, here's my question to you. Lead has 2 possible oxidation states. Remember what lead had? 2 and 4. So here's the deal. That could possibly be an answer choice. The last one couldn't have been because what was the metal? 10. 10 did not have a 1. 10 only is 2 or 4. So this could be. But again, I told you that the hardest part is catching something that's wrong. What's wrong up here? Johnny, what's wrong? What is sulfur supposed to be? How do you know it's supposed to be 2 negative? It's in group 16. So here's the process. What do you do to those numbers? Multiply them by 2. Multiply them by 2. Very good. So this is now 4 plus, and this is now 2 minus. So here's the deal, and I want to show you one additional thing. If it was originally PB 4 plus S 2 minus, what would you do with those charges to get the formula? You would have written PB2S4, but you've seen this story. What do? You got to reduce them. So that's where the formula came from. All right, so let's go back and let's look at it one more time. So now, what is the correct charge on lead? 4. So, trick question. What's the Roman numeral for 4, Natalie? Don't say it. Anybody say it out loud. Emma? Rizzy? Very good. IV. Okay. Those are things you got to remember. All right. I want you guys to do one on your own and see if you can figure it out. Yes. All right. Right? Do this one. Do this one. All right, Michaela, help me out. What is Fe? It is iron. Michaela, is iron a metal? Yes, Michaela, is iron a transition metal? Jamila? Yes, it is. All right, so is it one of our exceptions? No. So I need a what? Roman numeral. You do. That's what I'm saying. That's why I'm putting the blank there. So all right, now, so it's iron blank something. What is the something? What is the N? What does it end in? Ide. All right, so here's the deal. This Roman numeral, Ryan Howard, comes from what? Where do you get the Roman numeral from? On? Metal. Well, Michaela, that's empty. How do I get it there? Reverse crisscross. All right. So, Michaela, what's understood to be in that red circle? What's understood to be in that red circle? A 1. So I've got 1 plus and 1 minus. Now, I want to say this one more time. There's 2 things. Number 1 is, it doesn't matter what side the positive or negative goes on. Not at all. Don't care at all. My second question is, does it matter if the positive or negative comes first? Oh, that's the same stupid question. Here's my question. Does this or that matter? No, doesn't matter a bit. But the question I was trying to refer is, does it matter what side the cation or anion comes on? Yes. All right. I still messed it up, didn't I? That's okay. But here's the deal. We've got iron to be 1 plus. You should know by this point iron can or cannot be a 1. Cannot be. It can only be a 2 or 3. 2 or 3. So, Michaela, this is wrong. What's the specific thing that's wrong that lets you know that it's wrong? All right. What group is nitrogen in, Michaela? All right, so what is nitrogen supposed to be? 3 negative, right? So how can I turn that -1 into a 3 negative? Multiply everything by 3. All right? So that's going to change this to +3, and that's going to change this to -3. Now are we accurate? So what iron are we working with? Iron 3. Yes. No. It'll always be a whole number. A whole positive number. Okay? Because it doesn't matter. It's the absolute value because one side's positive, one side's negative, so it doesn't matter. Okay? All right. So we're good on that one. So here's what I want to do now. Number 22. For each of the compounds below, has anyone done that entire table? So 3. So that means we all need to do it. So here's what I want us to do, and I'm going to give you guys a chance to do this on your own. I'm going to help you do the first. I'm going to help you do the first one and the second to last one. Nope, actually the first one and the fourth one. So I've got a list of compounds, and then it first says metals that form only one ion and metals that form multiple ions. So here's what I want you to do. First of all, what is the metal in CABR? It's calcium. So my question to you is, what group is calcium in? It's in group 2. So what does calcium's charge have to be? 2 plus. So do me a favor. In this row right here, put Ca 2 plus. That's what it has to be. Now, the question now becomes, do I need a Roman numeral for this thing? No. And it says right here, because it only forms one ion, so it doesn't matter at all. I could care less what it's going to be. So the name, we're just going to write as calcium. Now I'm going to ask this question to Anijah. Anijah, why is the name of this thing not calcium dibromide? Very good. It's an ionic compound. That's the answer. So what is it, Anijah? It's just calcium what? Very good. It's just calcium bromide. All right, Blaze, I'm going to ask you this, and I've already given the answer to this question. Why is there not a Roman numeral of 2 in that answer? Very good. And it's a group 2, so we always know it's +2. Everybody okay with that? I'm going to help you with one more. Let's look at this one. Okay. Bailey, what is SN? 10. Is it a transition metal? Yes. Okay. So it has more than one possible ion. Do you happen to know what 10 states are? Very good. It's going to be SN2 plus or SN4 plus. And you as a group, have to figure out which one it's going to be. So I know it's going to be 10 something blank, the Roman numeral. And then Bailey, what's the second word going to be? Chloride. Very good. Why is it not dichloride? Very good. It's ionic. All right. So here's what we got to do. We got to figure out what the Roman numeral is in this thing. What is the process called to determine Roman numerals? Reverse crisscross. So when I pull back, I'm going to write it right here. Do you agree that I'm going to get a 2 plus and a 1 minus? Yes. So here's my question. Is this correct for chlorine? How do you know? It's in group 17, and what's the charge on all group 17s? -1. So if chlorine's right, then it's 10 right. Yes. So what is our Roman numeral that fits in that blank? 2. Very good. So that is your answer. Yes, sir. Gotcha. Thanks, sir. Who does? I don't know. Who's the teacher? There you go. Okay, yeah, you're good. So here's what I want you guys to do for the next 10 minutes. I want you to go through and answer these. Now, I'm going to put little stars besides ones that you need to be careful on. Be careful on this one. Be careful on this one. And be careful on that one. So those are the three that you need to pay very careful attention to. So for the next 10 minutes, work on those. All right, most of you guys are finished. So, Robin, we're going to start with you. We're going to work our way back, okay? Robin, Mg. What is Mg, Robin? Magnesium. What group is it in? It's in group 2. So, does it have more than one, or is it just one? Just one. And what's the charge going to be? 2 plus. So, does it need a Roman numeral? No. So, it's just going to be magnesium what? Magnesium oxide. Guys, y'all stay with me, Brett, please. Okay? Now, let me ask you this, Robin. Why is it not magnesium monoxide? It's an ionic compound. And what do we not have in ionic compounds? Prefix is very good. Now, Massimo, I'm going to pick you because you actually asked me this question, and I just want to make sure that we're all on the same page. Silver. What is special and kind of odd about silver? It is an exception, but it is a transition metal. But it is one of the exceptions. But what does an exception mean? What are you even talking about? Very good. Why does it not even need a Roman numeral? You need to know the except. Why it doesn't need one? Jamila? And only forms one ion. Massimo, do you know what the charge on that one ion is? What plus? 1 plus. Very good. That's the only thing silver ever has to be. So you don't have to tell me silver 1. I know that because I have it memorized. All right, so it's going to be silver. Okay. And then what's the next part of it going to be, Massimo? Nitride. Now, Massimo, why is it not trisilver? It's an ionic compound, and what do we not have in ionic compounds? We don't have prefix. Okay, very good. All right, Johnny, we'll go to you. We've already done that one. So Cu. Johnny, what is Cu? Is it a transition metal? Yes. Okay. So can it have more than one charge? Yes. Johnny, what are the charges of copper? Do you know? Very good. It's either 1 plus or 2 plus. Well, that's the challenge. We got to figure out what it is now. So we know that it's going to be copper something. And then what's the second word, Johnny? Very good. Fluoride. Why is it not difluoride? It's ionic. Very good. And what do we not have in ionic compounds? Don't have prefixes. Guys, I'm telling you now, if you put a prefix on an ionic compound, we may have to have a Come Jesus meeting. Because how many times have I said that? At least 100. At least 100. Okay? Don't be that idiot. And I'm saying it. Don't be that idiot. Okay? Now, Johnny, let's keep going. So we got CuF. Johnny, so here's the deal. How do I find out what my Roman numeral is? What's that process called? Reverse crisscross, right? So when I pull back, actually I forgot the 2 here. So I'm going to get a 2 plus here and a 1 minus here. And so here's the deal. We need to check that thing right there. And Johnny, is that the correct charge for fluorine? How do you know it is? No. What group is fluorine in? 17. What's the charge on all group 17s? -1. So it's right. So if fluorine's right, copper's right. So which copper are we working with? Anybody? Copper 2. Now, due to time, I want to do the anybody out loud, what is the next one? Potassium phosphide. Romy, I'm going to pick on you. Zinc. Why is it weird? Very good. And what is that charge on zinc, Romy? Very good. That's one of your exceptions. You have to have that one memorized. So zinc, and then what's the last word? Zinc what? Nitride. Very good. Guys, I'm going to be honest with you about this last one. I absolutely despise and hate all mercury compounds. Jamila, do you have a question? Or your hand's just dancing? All right. I hate mercury compounds, and here's why. Because all three of those are all possible and they're all different. If I ever give you a mercury compound on the test, make me let you omit it because it's not fair, because I despise them. And here's why. So this is the one that's on y'all's sheet, correct? HGO? All right, so here's the deal. We know that it's mercury. So here, what I have to do to find the Roman numeral to this thing, I got to reverse crisscross. That would give me a positive one and a negative one. But what's wrong with oxygen? It needs to be a 2. So multiply both of them by 2. That gives me 2 plus. That gives me 2 minus. So which mercury is this? Mercury 2 what? Oxide. So here's the crazy part. If I look over here, the thing that you guys don't understand here is that 2 doesn't belong to that oxygen. It technically belongs to the mercury, because this is mercury 1 oxide. Remember that polyatomic you guys had to memorize? That's it. And it's hard for you guys to understand. Y'all would want to pull this 2 back, and you can't because it's attached to the mercury. Just like over here, this is mercury 1 peroxide. Can I show you? Do y'all remember memorizing this? Stay with me real quick. I promise it's fast. You memorized this, right? You also memorized this. Peroxide. What happens to your 2 plus and 2 minus? So you're left with Hg2O2. No, they have to stay, because that's a part of the formula itself. And that's why I hate mercury compounds. It's very hard to determine which mercury you're talking about because they're so similar.